Alright, this video is about how I have embraced Alain Connes' foundation of reality as the origin of the passing of time, in contrast to the standard relativistic quantum model whereby the quantum field theory assumes a symmetric space-time as the foundation of reality, and this is what the transactional model, the relativistic transactional model, still maintains from Dr. Ruth E. Kastner. So I'm gonna explain how what she is saying is fundamentally different than what Alain Connes is saying. So she's talking about symmetry breaking creates temporal direction. So this is the way of stating that she says that the virtual photons are symmetrical, are highly symmetrical. But Alain Connes is stating that the negative frequency as a virtual photon with the reverse time in the imaginary axis is non-commutative. And so by saying it's non-commutative, that means it's highly asymmetrical. And his whole point is that, as von Neumann realized, that the type 2 factorization is the true infinity that's unobservable as a non-commutative time and frequency, or what Roger Penrose calls fundamental time, as the imaginary axis or the third dimension of time, and that's non-commutative. And math professor Luke Hoffman calls it primordial time, and Alain Connes calls it primitive time. And so Penrose and Alain Connes, they're both saying that ever since the Big Bang, there's a inherent direction to space-time. And so that's the symmetry that creates the temporal direction. So the Olivier Costa de Beauregard was the very first person to advocate for a transactional model of quantum mechanics based on relativity. And his idea is that there is based on the debate that Ritz had with Einstein, and Ritz being the creator of the Ritz-Rydberg law, that Ritz believed that there is a convergence from the future of space-time, that it converges back into the particle as a reverse time energy, and this is what is the origin of the negentropy, or negative entropy. And so what she's saying, Dr. Kastner is saying that convergence has to be true randomness, because it's indeterminate. And see, the whole point here is that in quantum physics, based on the Copenhagen interpretation, they're assuming that based on the statistical partition principle, the equilibrium partition principle, that therefore the just because it's indeterminate, it is also random. But math professor Ian Stewart states on quantum mechanics that just because it's indeterminate does not prove that it is inherently random. And what Alain Connes he did his PhD thesis on, and then he collaborated with the physicist Carlo Rovelli, that they argue that the origin of the direction of time is due to the thermodynamics and not to the symmetry of space-time that is then broken. So Dr. Kastner is arguing that the virtual photons are highly symmetrical, and this is also what Olivier Costa de Beauregard argued. And then he said it's only after we can observe the emission of the photon from the electron that therefore we experience the asymmetry of time in one direction, and that's why it's called symmetry breaking. And that's what thermodynamics is that we can only observe an increase in entropy as the inherent direction of time, and so that the entropy is a highly symmetrical randomness. But the noncommutative matrix argument is using a different mathematics. So you're not assuming a Fourier time frequency uncertainty as the origin of the conversion to an amplitude squaring for the amplitude as defined by a symmetric irrational geometry in the Fourier analysis. So this is why Alain Connes, he brings it right back to music theory. He's saying that if you use the example of music theory, the frequency is 3, but it's not symmetric with the octave as the scale or spectrum as 2, so that you can have a perfect fifth as 2/3 that is not allowed in the scale because it is asymmetric or non-commutative with the 3/2 which is also a perfect fifth, but it's within the scale because it's an overtone of the fundamental frequency as a 0 and a infinity, or a 0 and a 1. So in the first case that I mentioned yesterday, the type 1 of the von Neumann factorization, that is the equivalent of a double octave from the origin of magnitude in Western science based on irrational symmetric geometry, or the conversion of space or of time into spatial measurement. So in relativity, they're assuming that time is a symmetric spatial measurement. But if you look at just time and frequency, as Louis de Broglie realized, then you have a period of time that's asymmetric or non-commutative to the frequency. And so this is the true origin of the negative entropy, and it's not random, and it is unobservable, but it can be listened to because we can listen faster than the time frequency uncertainty or Fourier uncertainty as a quantum coherence. And in quantum biology, the ultrasound that we can listen to as the highest pitch we hear externally resonates the brain internally as ultrasound, which has now been proven to be a quantum coherence that's non-commutative due to the metamaterial of the tubulin with the microtubule inside the neurons of the brain. And this is what Roger Penrose and Stuart Hameroff are arguing, that the quantum coherence that resonates at the ultrasound at 3,000 times greater than any other frequency is due to the microtubule as a metamaterial quantum beat or subharmonic, an undertone that's non-commutative with the tubulins, so that you have a negative frequency and reverse time virtual photon energy that can be absorbed through the tubulin and microtubule. And this creates a magnetic moment that then stores the deep memories and also the energy of virtual photons, and that's what enables precognitive visions. And so Dr. Stuart Hameroff goes into the precognitive visions in his article on free will and the quantum consciousness. And so Dr. Kastner goes into free will, but she's using a totally different model because she's not acknowledging what Roger Penrose is now acknowledging, that the origin of reality as proto-consciousness is non-commutative time frequency energy, and that mass originates from the frequency that's non-commutative, and this enables signals from before the Big Bang. So Alain Connes is saying that ever since the Big Bang, yes, there's a direction to space-time based on defining time as a symmetric spatial measurement, but that even because of relativity, we have to analyze the redshift of light, also due to the quantum non-commutative change of time and frequency, and we have to take that into consideration. And then it works vice versa, as Professor Yvette Fuentes has been researching with Roger Penrose, that the quantum entanglement is whenever there's a change in acceleration, even at the small scale, then you have the space-time inducing non-locality, quantum non-locality. So it works both ways. And what Alain Connes is arguing is that our perception of the linear passing of time as entropy, as an increase in entropy, is not due to the symmetric space-time, but rather due to the inner fluctuations or inner automorphisms of the von Neumann type 2 factorization of the matrices of the Heisenberg interpretation of the observable photon emission. So Dr. Kastner, she's talking about the photons. She's going into the probability. So that right here she's talking about the location of the photons. So the virtual photons that are not on the mass shell, but also to photons that are asymmetrical relationship among charged particles. Such a photon may arise in a strongly asymmetrical relationship, for example, between the excited atomic electron and one or more ground state electrons. And if the energy of the photon is equal to the difference between the electron's excited state and the available lower state, the photon acquires a well-defined emission point, namely the excited electron. So this is the de Broglie law of phase harmony as a relativistic quantum dynamic, but you can see here it's based on the asymmetry. And what Professor Fred Alan Wolf points out is that Schrodinger, he realized that the photon emission was a subharmonic or an undertone of a higher time frequency resonance, but because Schrodinger had ignored the relativistic critique of de Broglie, even though Schrodinger was relying on the de Broglie wave model of reality to create the Schrodinger calculus of the wave equation that relies on the Fourier analysis of the wave equation. this is what created the measurement problem in quantum physics, because as soon as you convert the non-commutative time frequency into an amplitude measurement, because it's non-commutative, therefore it's inherently there's an inherent uncertainty, because if you go back and try to take another measurement, it's going to give you a different answer. And this is what is the inherent indeterminacy, but that does not mean it's inherently random. And so this was the problem with the transactional interpretation from Feynman and then Olivier Costa de Beauregard, and Feynman was taught by John Wheeler, so they were all relying on relativity as the foundation, which then became the quantum field theory. And Professor Jean Bremont, he says that the quantum field theory ignores the fact that the Bell's inequality experiment has proven that there's not a symmetric rest frame as a 0 point of spacetime due to the non-locality of the EPR being inherently indeterminate. So there's absolutely no way you can have a relativistic symmetric spacetime as the foundation for the quantum field theory if you analyze the EPR analysis. And this is Jean Bremont's big point, that he says if you look at a quantum field theory textbook, they will not analyze the EPR, the Bell inequality experiment, and that was a test of the EPR equation in terms of the Bohm-Aronhoff model. And whereas the Aronhoff has continued, and Bohm, they both realize that it's inherently non-commutative, so that the modular momentum enables a reverse time and negative frequency that they actually call a negaparticle as a origin of a mass, of a negative mass, not just a negative charge. So they're able to actually model the momentum of the vectors as a reverse time non-local field for the double slit experiment by using entangled photons as the weak measurement experiments. And this proves that that there is a field that it doesn't rely on any velocity of the speed of light, but it's just a non-local, non-commutative fifth dimension that's pure time and frequency, and secretly guides the particle from the future. And it's not random, but it's just unobservable because of the linear operator of time and frequency in science. So the